Good morning. Let us discuss a very important problem on Gauss's law in electrostatics. Here the problem is a sphere of radius a has a charge density which varies with a distance as rho equal to capital A times root over r, where A is a constant. How does the electric field vary with r for r less than A? So this is the problem, and now we shall try to understand this problem very well, and then we will discuss about the solution of this problem. First of all, a question may be arised that what type of sphere it is. Is it a hollow sphere or is it a solid sphere? The answer is, here the sphere is the solid sphere. But how can we understand that this sphere is solid sphere? This equation in this problem indicates that the sphere is solid sphere because the volume density of charge is denoted by rho, and the equation gives us the volume density of charge of the sphere, and a solid sphere corresponds to volume density of charge, and a spherical shell or hollow sphere is always correspond to surface density of charge, but a solid sphere is corresponds to volume density of charge, and this equation gives us volume density of charge, and volume density of charge is denoted by rho, and here capital A is a constant and small a is the radius of the solid sphere, and here r is the distance of a point from the center of the solid sphere, and which is inside the sphere. The point is inside the sphere. The point which is at a distance r from the center of the sphere is always inside the sphere. How we can understand it? That from this part of this problem, r less than a indicates that the point where the volume density of charge is given by this equation is inside the sphere, that is inside the surface of the solid sphere. Because of small a is the radius of the solid sphere here, and r is the distance of a point from the center of the solid sphere, and which is less than r, that is which is less than radius of this solid sphere, that is the point is inside the surface of the sphere. Now we have to calculate electric field at that point where the volume density of charge is given by this equation. We have to calculate electric field at the same point which is at a distance r from the center of the solid sphere. So in this problem, if we consider a point inside the solid sphere which is in between the center of the sphere and the surface of the sphere, the volume density of charge at that point is given by this equation, and we have to calculate electric field at the same point which is in between center and the surface of the sphere. And then we can easily say how does electric field vary with r when r less than a. That is, the distance of the point from the center of the solid sphere is always less than the radius of the sphere. That is, for an inside point, how electric field varies with the distance from the center of the solid sphere. So, before discussing the problem, we consider first three assumptions for easy to understand this problem. And first, let us see. We consider a point P in between center and surface of the solid sphere, which is at a distance r from the center of the sphere. So we consider a point in between center of the sphere and the surface of the sphere, and that point P is at a distance r from the center of the sphere. Number 2, we consider a Gaussian surface through the point P. Gaussian surface is an imaginary surface, and we consider here a Gaussian surface through the point P, which is in between the center and surface of this solid sphere. And next 3, we consider charge inside the Gaussian surface is Q. That is, this Gaussian surface encloses a Q amount of charge. We consider this. So let us see the main solution of this problem. We have from Gauss's law in electrostatics, closed surface integral E dot ds equal to Q by epsilon 0. This is equation 1, where epsilon 0 is the permittivity of free space and Q is the charge, and here the charge Q is enclosed by the Gaussian surface S, and closed surface integral E dot ds means total flux through the Gaussian surface S. Here S denotes the Gaussian surface which encloses the charge Q. So total flux through this Gaussian surface is Q by epsilon 0, and this is Gauss's law in electrostatics. So now charge enclosed by the Gaussian surface is Q equal to, we can write 4 by 3 pi r cube times rho. If we see the definition of volume charge density, then we can easily write this equation. Volume charge density means charge by volume. Here the volume corresponds to the volume of the solid sphere. So we can write the volume density of this solid sphere rho equal to Q by 4 by 3 pi r cube. But we have to minutely see this equation. This 4 by 3 pi r cube, this is the volume of a sphere of radius r. This is not the volume of the whole sphere in this problem, but it is the volume of the portion of this sphere, and it is the volume of the portion of the sphere which is enclosed by the Gaussian surface, and here r is the radius of the Gaussian surface. So 4 by 3 pi r cube is the volume of the portion of the solid sphere which is given in this problem, and the portion which is enclosed by the Gaussian surface and whose volume is 4 by 3 pi r cube. And rho is the volume density of charge of the whole sphere, and q is the charge enclosed by the Gaussian surface. 4 by 3 pi r cube is the volume of the portion which is enclosed by the Gaussian surface, and rho is the volume density of charge here. So this is equation 2. Now if we use equation 2 in equation 1, then we can write in equation 1, in place of q, if we write 4 by 3 pi r cube times rho, then we can easily write at the right hand side of this equation 1 by epsilon 0 times 4 by 3 pi r cube times rho, and in the left hand side of the equation we can easily write E times 4 pi r square, where r is the radius of the Gaussian surface and 4 pi r square is the total surface area of the Gaussian surface, which encloses the charge of amount q and which is equal to 4 by 3 pi r cube rho. Now if we simplify this equation, we can easily write E equal to rho r by 3 epsilon 0. This is equation 3. And by question we can write rho equal to capital A times root over small r. This is equation 4. From question we can get this equation, rho equal to capital A times root over r. And if we use equation 4 in equation 3, we can get this equation, E equal to A times root over small r times this small r by 3 epsilon 0 using equation 4 in 3. If we put this equation in place of rho in equation 3, then we can write this. And next step, if we simplify it, then we can easily write A by 3 epsilon 0 times r to the power 3 by half. Because of root over small r means r to the power half times small r means r to the power 1, and if we simplify this, then we can write r to the power half plus 1, and which gives us r to the power 3 by 2. Now by question A is constant and 3 epsilon 0 is also a constant. So A by 3 epsilon 0 is a constant term. So I can easily write E proportional to r to the power 3 by 2. So this is the required variation between electric field with distance from center of the solid sphere and which is inside the sphere. So the question was, how does the electric field vary with distance from the center of the solid sphere, that is vary with r for r less than a, that is for inside point, how electric field vary with distance from the center of the solid sphere. So the answer is this: the variation of electric field with distance inside the solid sphere is E proportional to r to the power 3 by 2. So this was the solution and this was the discussion today. So thank you so much for watching this video.